Good afternoon, lockdown bioinformaticians, and welcome back to Lockdown Learning. A week is a long time, it seems. It's been a bit of a break for me, and maybe a bit of a break for you as well. But welcome back, and let's get prepared to do a bit more lockdown learning. So this time last week, which was our last session, I tried to introduce the Git version control system, and we spent what turned out to be a little bit over an hour introducing the very basics of Git, so the verbs that you need to get Git up and running for local version control. And where I came a little bit of a cropper was in an unexpected problem with pushing my local changes up to a remote repository. So I showed you setting up a repository on GitHub, and the idea was then to push the local repository, the contents of our local repository, up to our remote repository on GitHub. And that's where I came slightly unstuck due to a slightly unexpected problem with authentication. Which I wasn't expecting, and which was a little bit unfortunate. But it's something it was very difficult to resolve live, but I've resolved since. And I did kind of say, when we started our weekly schedule last Wednesday, my idea was always to never go back. That's the point at which you say, okay, from now on, we will do something new, something different every week, and we won't go back. We won't necessarily have that connection between one week and the next in the way that we did previously between one lesson and the next. Well, they say no plan survives first contact with the enemy. The enemy in this case, as I think I posted on Twitter this afternoon, being my own ability to not stop talking. And also it turns out my continual ability to not quite prepare for every eventuality. So despite my best laid plans, we are going to continue this week with Git and GitHub, because I feel like we left it a slightly unsatisfactory place last week. And I talked to you about pushing and pulling, but I couldn't really demonstrate them. There's never anything quite like seeing something in action in order to get a real feel for how it works properly. So with that in mind, that's what we're going to do this week. So I've now got things set up so that we should be able to push things to GitHub quite happily. So if we let's start right there. Let's start with my GitHub repository for the test repository that we were building last week. So this is on GitHub. This is publicly available on GitHub, so you can go and have a look at this. This is a repository on GitHub which contains the contents of the repository that we were building last week by way of example. So it at the moment contains just a README file, and that you can see that README file because GitHub is clever. It shows you the contents of the README file, because the idea is that if there's a file called README, that is the first place that's going to describe a project, and so GitHub extracts the text of the README file and shows it to you. If your README file has Markdown in it, and we talked about Markdown in the context of R Markdown a few weeks ago, if your README has Markdown in it, GitHub interprets and renders that Markdown as well. So GitHub's quite clever about the way that it deals with README files. But that is the only contents of that project as it currently stands. This one file with these 3 lines of text. But our GitHub repository is exactly up to date with our remote repository, as far as GitHub is concerned, that is our repository on our local machine. Okay, so the two things are currently in sync. And what we can then do, so now that we've got things set up properly and I've got my authentication sorted, now I can make changes locally and then reflect those changes in my local repository by careful use of the correct Git commands. So let's say we're going to create a script in our repository. Okay, so let's make an entirely new file. So we're going to use nano to make an entirely new file. We're inside our Git repository, so you can see in my terminal here, my current working directory is home/code/ldl test. This is my local copy of this Git repository. If I do ls with the -a flag option, you can see that we have our .git directory in this current working directory. That's the thing, if you recall from last week, that .git directory, the presence of that defines this as a Git repository. And Git understands that the presence of that directory and the things that are in that directory are what define this as a Git repository, and also define the status of this Git repository. Speaking of status, we can check on that with the command git status. That will tell us what the status of our current project is. Now that we have remote as well, so Git is reporting nothing to commit because we haven't made any changes since our last commit. It's also saying it's up to date with the remote, where the remote here is called origin/master, which is the default name of a remote repository. Okay, we can so we can now make changes to our repository. So we're gonna, as I said, we're gonna create let's create an example script, and it's going to be a bash script. So so it's a bash script, so #street bin bash, then echo. Okay, so we've been here before. Okay, very simple one-line script to echo hello world. We're going to add this into our repository, commit it, and then we're going to push that change up to GitHub without leaving the command line. Okay, we don't need to leave the command line to do this. So we're going to save this file, Control O, and then exit nano, Control X. And now when we type git status, we will find out that we have an untracked file. That is the example script.sh file that we just created. So that's now an untracked file. Because we've created it, we've given it kind of, well, the fact that it exists is enough for it to be an untracked file, but we haven't staged it. We haven't told Git to track it yet. So it's a new file that Git isn't currently tracking because Git doesn't know about it yet. So in order to get Git to track it, we need to use git add. So we're going to do git add and then the name of the file that we want to add. And now Git will be tracking that file. So there you go, we have a new file, and this is a change which we are now able to commit to Git. So we've made this change, and now we can use git commit with a message. So let's say added example script.sh. Right, descriptive commit that lets us know what it is that we've done. So that's our message, and this will commit this change into our repository. So this will effectively take a new snapshot of our versioned repository. So there you go, we've added that new file in. And again, if we do git status now, so git status is this command that you keep coming back to that tells you where you're at compared to sort of where you're at in terms of your current repository. So now git status is telling us that there is nothing to commit. Okay, so nothing to commit. because we've made our change, we've added it, and then we've committed it with an appropriate message. But the other thing that git status is telling us now is it's saying that my branch, so here, my branch here, is ahead of the remote branch, origin/master, by 1 commit. Okay, so this is telling me that my local branch now is ahead of my remote, and that in order to catch up, in order to publish my local commits to my remote, I need to use git push. Okay, so if we take another quick look at GitHub, so let's bring GitHub back up, just to show you that nothing has changed, right? So I can refresh GitHub. So if I hit refresh in Chrome, I can refresh GitHub and nothing has changed. Okay, there's no, although I know that locally I've made a new commit, GitHub knows nothing about that commit. So this is a change which currently has only happened locally. Okay, so how do we get that change up to GitHub? How do we get it up there? And the answer is, well, we push it, and we push it using git push. So by default, what you have to do is tell git the remote that you want to push to, so that's origin, and the branch at that remote that you want to push to, which in our case is master. Okay, so git push remote branch, so git push origin master, and that will push this version of our current local repository to our remote repository, which is my GitHub repository in this case. If the last time you pushed to origin master, you don't need to include origin or master in this git push. It will, by default, git will push to the last place you pushed to. So unless you're changing your remote, and a repository can have many remotes, so unless you're changing which remote or which branch at that remote you're pushing to, you don't need to define it at the command line. So I have pushed to this repository before, and the last time that I pushed was to origin master. So git push will suffice for taking those local changes and reflecting them on my remote repository. And my remote, if you remember, we added it last week. My remote is this repository on github.com. Okay, so that's defining my remote there. So now if we bring GitHub back into focus and refresh the page, what you should now find is we've just pushed. So we committed this 4 minutes ago. We've just pushed it. And that change has now been reflected on the GitHub website. So that script that we just created, we've pushed it up to our remote repository, and there it is now on the GitHub website. And I can click through, and you can see that the content on the GitHub website is exactly the same as the content on my local machine. Okay, so this change didn't take effect until I ran that push. So until I took my local commit and pushed it to my remote repository. And that is always true. That's always the case. You need to actively push your changes to your remote repository. Git won't try and take care of that on its own by default. So the other thing that we need to think about is then changes to what's in your GitHub repository that aren't necessarily reflected locally. And there's ways that this can happen. You can add users. You can give other users write privileges to any GitHub repository that you own. So GitHub is a collaborative platform. So you could give your lab mate write privileges to your GitHub repository so that you can collaborate on code together. And so they could be making changes to your code, and you might want to catch up your current version, your local version, to any changes that may have happened on GitHub since the last time you worked on the code. It could also be that you want to work on your own code in multiple places. So it might be that you want a local version on your computer at home and a local version on your computer at work, and you want to keep those two versions in sync. But so you might do some work at home in the evening, commit that work to GitHub, and then in the morning you might want to catch up your local copy at work to the version at home. Now, obviously, at the moment, depending on various states of lockdown and whatever, and as I said, a week's a long time, and a lot's changed this week in the UK anyway. But for me, there's no distinction between home and work at the moment, so I don't really have that issue. But there's a computer on my desk at work. It's a desktop computer. It doesn't come home with me, and I could see situations in which I would do a little bit of tinkering in the evening and want to catch my code up in the morning when I get to work. And so you need to be able to deal with situations where your remote has changed and your local therefore is out of sync. So we can simulate this just quickly by making a change on GitHub. So GitHub lets you edit the files locally, so I can make changes on GitHub, and GitHub treats these changes as Git commits. So it's under the hood, GitHub is using Git to track these edits as I make them. So I've pressed edit on this file on the GitHub website, and I can make changes. Okay, so I can say sleep 10 and then echo all done. Okay, so just a couple of extra lines. And then on GitHub, I can commit this as a change. So this is a website-based interface to Git, essentially, where I can take this change that I've just made to this file, and I can commit it, and I can give it a commit message. So I have updated example script with a sleep. Okay, a little bit descriptive, not too long. What email address do I want to associate with the commit? Because that's the options from my account, my GitHub account. Commit directly to the master branch. I'll talk more about branching shortly. But this creates a commit on my master branch. Now my GitHub is different to my local. Okay, so my GitHub version of this repository, my remote, has changed. So this is my example.sh script, which is different now to the version in my local. I've now made 6 commits, whereas before I'd made 5 commits. My last commit, you can see, was 24 seconds ago. This repository on GitHub is now different from the same repository that I have stored locally. And so we can show that, and this should work. If I do git status, now it's telling me I'm up to date. And this is the thing where it's slightly misleading. Actually, I'm 1 commit behind, but I don't know that I'm 1 commit behind because you're not automatically updated with it like you are before you push. But in order to get up to date, I have to do the opposite of push, which is pull. Okay, so git pull. Again, git pull origin master would be the full command, assuming that you want, in the situation especially where you wanted to pull from a different branch or a different remote, you would have to be explicit about it. But the last time we used a remote repository, it was origin master, so we're sticking with the same thing. So we're doing git pull. So there you go. That has pulled down the change from GitHub. So we've updated from the commit we were at locally to the new remote commit. That's this identifier here, which we can check on GitHub. There's the ID of the commit, 0b12598 on GitHub. And you can see that that's the same, that's this 0b12598 is the same ID of the commit here. So we've shipped forward to this commit that was on our remote repository that wasn't on our local repository. The number of files hasn't changed. We've still got the same files as we had before, but our example script has changed. Okay, so I've not touched that file in my terminal, apart from via Git. It's Git that has made the updates to that file via Git pull. So by pulling the remote changes, I have updated that that file using Git pull. Okay, so that is push and pull, and push and pull are obviously, when you're working with GitHub, they're extremely useful, and GitHub is really, for most people using Git, GitHub is going to be the platform that enables collaboration via this system. So GitHub is going to be the way in which you and a coworker or a collaborator can work on the same set of files and keep up to date with each other. And Git is hugely useful for that. It's very, very useful for enabling that kind of working. The only thing where you get into where things get sticky is where you and a co-worker have made changes between syncing up repositories. You and a co-worker have made changes in the same file, and that is where you'll end up with what are called conflicts, and you need, before you can carry on working with your files in Git, then you need to resolve those conflicts. It's usually fairly easy to do, because usually people are working on different bits. Even if it's in the same file, they're working on different bits of the same file. But when things conflict, that can be problematic. Does Git pull overwrite local files? Yes, it will do. Although sometimes you'll get conflicts as well, I think, and it might be worth testing that. What I am just gonna do over the next 5-10 minutes is I'm going to try to set Git up on my VM to try and kind of simulate two people working on the same code in two different places. So I can make edits on GitHub, and that kind of shows you how that works. But there's nothing quite like having the same repository in two different places. So therefore, that's RStudio. Where is my VM? Here it is. There we go. So here's my VM. So it's my lockdown learning Ubuntu 1804 VM, which we've used time and again. I'm going to open my terminal, and the first thing that I'm going to do is I'm going to install Git, because what you will find is that by default on Ubuntu, Git does not come pre-installed. So we have to install Git. So sudo apt install Git. So that's exactly the command that that Bash recommended to me when I tried to run Git without it being installed. So prompted for your password. So enter your password, and that will install Git and the dependencies for Git that are required for it to work. So what happened there? Do you want to continue? Yes. There we go. So now apt is installing Git for me. There we go. So we should now have Git installed. So what I'm going to do is I'm going to make a directory. I'm not going to do this in my share directory because I don't want to confuse the issue between files that are shared with my host machine and not shared with my host machine, because obviously all of the Git stuff that I've done recently has been on my host machine, so I don't want to get those two things confused. So I'm going to make a code directory. I'm going to cd into there, and then I'm going to clone this repository from GitHub. So actually the other thing I want to do, bear with me a second. There we go. So we've got a new installation of Git, so we need to set it up. So we're going to do git config global. So I'm going to change the global config. I'm going to add a user name, user.name, my name, then git config global user.email, email for Git purposes, which is, it's important that it matches the email of your address, the email that you use at GitHub, for instance, if you're planning to work with GitHub. I'll just add git config global color UI true, and git config global core editor, and I'll set it to nano, so that if we're dropped into the editor, if I forget to put a commit message in and we're dropped into the editor, then it's an editor that you're familiar with. Okay, so that's my config sorted, which is important. And now what we're going to do is we're going to clone this repository from GitHub. So there we go. Here is the GitHub. You've got a button on here which is clone, and it gives you, in here, gives you a URL for cloning it. So this string here is what you need for cloning this repository. So you do git clone and then this string in here. So here we go. So git clone, and then it is git at github.com :username / repository name, which is ldl_test.git. Okay, so the general form here is always git at github.com and then a colon, and then this is the name of the repository. So in this case, it's my username / repository name, and then it finishes with .git, and that is the general form for taking a copy of a repository from GitHub. Okay, so this is the first time I've used Git. Here is using SSH, so secure shell, to take a copy of this repository. It's the first time I've connected on this VM to GitHub over SSH, so it wants to check that I'm confident that I'm doing the right thing, which I am, so I'm going to hit yes. Right, and so because what I'm doing here, and actually this time I've done this deliberately, is I am hitting the same authentication problem on GitHub that I hit last week, which is that as far as GitHub is concerned, this machine that I'm using, this virtual machine that I'm using, doesn't have access rights to this repository on GitHub. It's not set up correctly so that I'm able to access this particular repository on GitHub. And the way that GitHub manages this is via what are called authentication keys. And so what you need to do is set up a pair of authentication keys on your VM and then give GitHub a copy of the public key. So a authentication key comes as a pair of files. There is a private file which you keep private, that you let nobody else see. And then there is a public file which, as the name suggests, doesn't really matter if who gets hold of it. It doesn't matter who has that public key, as long as you keep your private key private. And so you give the public key to GitHub, and as long as you've got the matching private key, then GitHub can pair those two things up and can know that you're authorized to access this repository. So we're going to generate a key pair, and we're going to do that using an executable, a binary on Ubuntu, which is called SSH keygen. So this is a tool for generating an authentication key pair, so SSH keygen. Okay, we're going to generate, so -t is the type of key that you want to generate. We're going to generate a type of key called RSA. There are lots of different types of key, but RSA is the one that's probably most commonly used. And that should be all we need to do, actually. So we'll run that, and we're going to enter a kind of interactive prompt with our command line now. So here we go. So we're being told here we're generating a public/private RSA key pair. Enter the file in which you wish to save the key. So by default, the private key will be in a file called id_RSA in a directory called .ssh in your home directory. Okay, so this is by default where your private key will be stored, and that is a perfectly fine place to put it. The public key will be stored in the same location, but will be called id_rsa.pub. Okay. Okay. You can protect your key pair with a password, which is always good practice. To protect your key pair with a password. For most systems now, once a key is protected with a password, your system's password manager will kick in and remember it for you. But just in case, use a password that is memorable to you. So I'm going to stick a password in here because that's good practice, and you have to type it twice. So never generate a password that isn't protected. Never generate a key pair that isn't protected by a password, because then even if you lose your private key for whatever reason, it's still password protected, and it's not a key that will let anybody access systems where the public key is stored. Okay, so that's my key pair has been generated. Okay, so your identification has been saved in /home/simon/.ssh, which is a hidden directory, /id_RSA, and it says the public key has been saved in home simon.ssh id_rsa.pub. Okay, and it's this public key, that's what we're going to give to GitHub for authentication purposes. You should never ever distribute the private key anywhere. That is your file to keep safe. Leave it where it is. Leave it on in your .ssh directory, because that's where your system knows to look for it. But that is that always has to be kept safe and secret. Never spread that file around. The public key on the other hand is your kind of, that's the second half of your authentication key, and that is the bit that you can pass on to other people. Okay, so let's just have a quick look in our where's my tilde? There we go. In my home.ssh directory, I now have these two files. This is my private key, which I'm not going to look at. This is my public key, which I can show you the contents of. .pub home slash .ssh. Okay, so that is my public key, and if you've generated a key pair, your public key should look similar with a similar amount of gobbledygook inside it. And what we want to do now is to provide this public key to GitHub, so that GitHub knows that this machine belongs to me and is authorized to access this particular repository. So to do that, we're going to log into GitHub. Actually, what I'm going to do is I'm going to put that into my paste buffer, copy, and then I'm going to go to my browser and I'm going to go to GitHub. Nicely, my browser's remembered me and remembered that I'm signed in. Right, so I'm signed in on my GitHub account here. Oh no, I'm not. Okay, bear with me a second. Oh, for God's sake. Okay, bear with me a second while I log in. Shouldn't take me very long. Okay. There we go. Okay. Okay, just entering my password in a place where you can't see it. Hopefully correctly. Okay, fine. This is not going terribly smoothly, but better than last week, I think. Feel free to correct me if you don't think that. Okay, we're getting there. We're getting there. We're getting there. I promise. There we go. Right. That is me. There we go. Take that away again. That's me logged in. There you go. So what we're going to do then is we're going to add this key. So we have to go into my, I think it's settings. And then here SSH and GPG keys. And we have to add a new key. Okay, so we're going to put in a new SSH key in here. The title is Lockdown Learning, and the key is what I've just copied and pasted out of my, so this is the public key that I just copied out at the command line. Okay, so I'm going to add this key. So this is the public key, very definitely the public key. I'm going to add this to my GitHub profile. That will trigger an email. I will now receive an email from GitHub. There you go, it's arrived, telling me that I've done that, informing me that I've done that. But the upshot of it is that now this machine will now identify itself correctly to GitHub when I try and do anything at GitHub. So now when I run git clone, there you go, it's prompting me for the password. This is not for my login to GitHub or anything like this. This is the password for the key pair that I just generated using SSH keygen. So I put in a passphrase when I made that key, and that's what it's prompting me for there. So I've entered that passphrase, and now Git has cloned that remote repository for me into my present working directory. So after git clone, I now have a copy of that repository here. I can cd into it. It's just a normal directory. It has the .git directory that's going to be very similar to the .git directory on my local machine. It's got the README file. It's got the example script. Okay, so let's make a change. I made this change on my VM. Okay, save it. We don't need to add it because we can do git commit. It's not a new file, so it's already tracked. We just need to stage the change, which we can do in commit with -a, and then we give our commit message a change on the VM. Okay, so that's our commit message. So let's commit that change. There you go. So that's a commit, and now you'll find that we're a commit ahead of the remote, because by cloning, we automatically added a remote to this repository, because this repository comes from a remote. So we can, because it's a clone, we can git push, and it will push to the place it was cloned from. Okay, so git push. Authentication will now work because we've set up our key properly. So now we can push to the remote location quite happily. And now if we bring our GitHub back up, here we are, and refresh. So I'm going to hit refresh. You will see that the change in the README was a minute ago. The commit message is a change on the VM, and we've got in the README we have the text that we added on the VM. Okay, so we've made the change on the VM, we've committed it, and we've pushed it to the remote repository. And now we're going into work the next day, and we know we've made those changes, or that somebody has made those changes since the last time we worked on our repository. So our local repository on this machine, so now I'm back on my host, I'm on my Mac, in my Mac terminal here. This repository is out of date. Okay, so I don't have that change that I just made on my VM in this repository, but I pushed it up to GitHub, so I can get that change, and I can get that change again via git pull, because I can fetch it from GitHub. So there you go, it's pulled that change down, and now my README file again reflects that change in the remote repository. Okay, so that enables me to work very effectively between two or even lots of machines. And as long as I remember, before I start working in a particular place, to use git pull to get the latest version, then we keep everything in sync. And especially if it's just you working on a repository, it should be relatively straightforward to keep things in sync. Okay, I want to talk about a couple of other things before I finish. The first of those is branching, which you can use to experiment with new things, and if they don't work, you can throw them away. If they do work, you can merge them back in. So it's a fairly common way of working with version control. So I'm going to talk very briefly about branching, and then I'm going to talk about I'm going to come back to clients. I mentioned clients last week, but I just want to come back and talk again about clients for Git before the end of today. Okay, so the first thing is branching. So Git, this is a verb for Git, which is branch. If you run it without any other arguments, it will just list the branches that are available in your current repository, and it will highlight the one in which you're currently working. So by default, when you initialize a new Git repository, the initial branch that you're working in will be called master. although there has been talk, and I don't know if this has been implemented yet, but there has been talk recently of that terminology changing because of the negative connotations of that particular word. And so there's every chance that this video is going to be out of date very soon if it isn't already, and that they've changed the terminology of the default branch in Git and on GitHub. But for our purposes right now, at the moment, that is, for better or worse, that's the name of the default branch in a new Git repository. If you want to create a new branch, okay, so Git branch, and then you create a new branch, and you do it just by naming it. Okay, so we're going to name our branch. I'm just going to call it new branch. Okay, just for by way of example. So this creates a new branch on your repository, and now you can list your branches again by doing git branch. And if you look, you can see that at the moment our active branch is still master. Okay, it hasn't changed, and that's because you have to activate your new branch to work on it, and you do that via checkout. So git checkout, and then you define the branch with -b, and you say, well, I want to work on this branch. Now, the reason for doing this is it might be that you want to experiment with something new, and you're not sure if it's going to work, so you want to test it, but you don't want to test it in your main repository because maybe there's other people working in there, and you don't want to pollute what they're working on with your new feature. Now, this is not necessarily often something that you will do if you're working in a repository on your own, but particularly if you're working with other people, having multiple branches can be a really effective way of keeping check on. Okay, sorry, you didn't need the -b. The -b would have created the branch if it didn't exist already, I think. But anyway, branching can be a really effective way of kind of keeping track of new things. It's also effectively what's used to do forks and pull requests on GitHub. It's the same kind of methodology. Okay, so we're in our new branch now, and we're going to want to start working on our new feature. So let's have our new feature script. Okay, so in here we're going to have a brilliant new experimental feature that's going to advance the field of bioinformatics by 10 years in one fell swoop. Because I have no imagination. There we go. Okay, so there you go. There's our brilliant new feature. So that's in our new branch, and now if we need to add. So hold on, let's get status first of all. Okay, so there's one new untracked file. This is behaving exactly the same way as status behaved on the master branch, and that's because we haven't yet. We're not yet in a position to. We haven't made any changes as far as Git is concerned to this repository yet, so we can add our brilliant new feature. To our Git repository, and we can commit it. With a message, new feature added. Okay, that's committed. You'll notice that this branch here isn't reporting anything about a remote, and that's because this branch is not connected to the remote. So it's slightly beyond the scope of what I wanted to do today and would take too long, but you can add the branch on GitHub and add it as a remote and have that branch synced up on GitHub as well without too many hassles using the techniques that we've already explored. Okay, so that is we've been working on our new branch, We've written some new code. We've committed it to our new branch. And we think this is the best thing since sliced bread. We've advanced the field of bioinformatics by 10 years in one fell swoop. So we want to get this feature into our master repository and quickly. Okay, so let's switch back to master using git checkout. Okay, so that switches us back to our master repository. And now if I list, what you will see is that our new feature script has gone. It's not there because it doesn't exist on this branch of the code. But no fear, we can switch back if we want to. So we can check our new branch back out, and we've got our new feature back again. But we can also merge them together. We can also merge our new feature script into our master branch, and I'll show you how. So we want to check out master again. Okay, git branch, just to show you what's going on. And then we want to do git merge, and then the name of the branch that we want to merge into this branch. So we want to merge new branch into master. And there you go. So that is what has now happened, is Git has merged our feature branch into our master branch, and we've acquired the new feature script in our master branch. So we're still on the master branch, and new branch still exists, but the two things are now in sync. Okay, so we've synced them up, and our new feature is present in our master branch. And you could now go back into your new branch and you could work on another new feature and continue to make new developments there before merging it back into master again. Or you can delete that branch. So you can delete the branches as well with git branch and -d. -d will delete a branch, a named branch. This actually does take me quite nicely into interfaces, interfaces to Git as well. I showed you briefly last week the GitHub desktop application for Macs, and it's also available for PCs. I'm just going to swap branches again just to show you okay, so I'm going to check out new branch again, and even though there's no differences here, I'm going to show you the current status of my GitHub desktop app. Okay, so this is the GitHub desktop app. I've got the current repository is LDL test. That's the repository we've been working in. There are no local changes, so there are no uncommitted changes in this repository. Although that's not strictly true. I haven't pushed my changes to GitHub yet. But anyway, what you can see is that it is saying there's a new branch. So the current branch, new branch, hasn't been published to the remote yet. By publishing it to GitHub, you can share it, open a pull request, and collaborate with others. Okay, so the GitHub desktop app has detected that I've created a new branch, that I'm working on a new branch, and it's offering me the ability to publish that branch up to GitHub. And so I'm going to click that button, and it's going to push that branch up. So it's just quickly working on that there. There you go. And now, if we bring GitHub up, you will see that, there we go, I've got some change. So it's saying new branch had recent pushes less than a minute ago. So we can compare, we can do a pull request on that branch, we can switch to it. So now it exists on GitHub with that new script in it. We can switch back to master if we want. In the GitHub app, so GitHub desktop, here we are, here's GitHub desktop. We can switch to the master branch. There you go. The master branch is up to date, is committed, up to date, but it is now out of sync with the remote because we've got the new feature script is committed to our master branch, but it's not pushed. And the GitHub desktop app knows that. So now we can push that change up to GitHub as well. And this interface, once you get used to it, is a really effective interface over the top of Git, and avoids you having to necessarily remember all of the different kind of command line tools and everything that you need to run with Git. So let's just recheck out our master branch in our command line, and let's touch a new file. And if we then flip to the to the GitHub app, you will see that new file has been added. So it's here, it's a new file, it's empty, but it's a new file, and we're being prompted to commit this change to our master. And we actually get a default commit message here. So create new file is like a default commit message, which we can use. So let's commit that. Now the GitHub desktop app knows that this is out of sync with the remote, so we can push our origin up to the remote, and off it goes. And okay, one last thing then. Here we go. We go back to GitHub and refresh. And there we go. We've got the new feature script is here. We push that up using the app, and new file is here as well. And we push that up using the app. I just want to quickly mention two other things. The first of which is a text editor. So the only text editor we've really talked about so far is Nano. But there's a whole world of text editors out there. A lot of them are a lot cleverer than Nano. One which I use a lot locally is actually made by the people at GitHub, and that's a text editor called Atom, which you can download from atom.io. So it's developed by GitHub, the company GitHub, and that means it integrates really nicely with Git and GitHub. So I'm just going to quickly pull up Atom. So I'm just starting it. Here we go. And so here is Atom, and I've opened a project. So you can add a folder in to a project, and that brings up this little pane on the left hand side, which shows you your project. So this is obviously this is my LDL test repository here. If I add new files into this repository, so give it a name, Atom file, it's highlighted in green because Atom integrates well with the fact that this is a GitHub repository. So you can see down at the bottom, there's all sorts of features that are presented in the Atom interface here, which are due to this being a Git repository. So you've got the branches are there. You can fetch from, because it knows that it's got a remote repository, so you can fetch from that remote if you want. You can, if you log into GitHub, you can get information about this repository on GitHub because it knows it's on GitHub, and various other things besides. It also knows that we've made a change here, and it knows that that change is also in the repository itself. So the repository is highlighted as having been changed. If we make a change in one of these files, then that change is also highlighted there in the file as being different from what is committed to GitHub. And again, if we save that file, it's highlighted as having been changed. So Atom is integrating well with Git here, and is keeping us kind of up to date. It's telling us that we've got 2 changes here from our last commit. So we've got local changes in our repository that we perhaps want to reflect. And to do that, we can make those changes, I think, here in so here we've got an interface to Git within Atom, which allows us to make that commit here within Atom if we want to. So you can see that we've got README has been changed, Atom file is new. We can add our commit message here, and we can commit that change. Apparently we can't commit that change. That's interesting. I don't know why that's not working. Equally, if that isn't working for whatever reason, GitHub Desktop knows as well, and we can add, changes made in Atom, and we can commit that, and then we can push it. So if you set Atom, take the time to set Atom up correctly, which clearly I haven't done, then you can use that text editor as an interface to Git as well. And then just the final thing that I wanted to do, because again, obviously I've run on and on and on because that's me. I talked briefly last week about RStudio as an interface to Git. We can, if we set up a project, an RStudio project in our repository here, then the Git tab here should know when we make changes that those changes need to be reflected in Git. So what we should get then is, so here we've got 2 files which are not tracked by Git. So our git ignore and the R project file that we just created, because we just created an RStudio project in this directory. If we now create an R script, and save it into our repository. Again, it appears here in the Git pane, and we can stage it, and then we can commit it. So the tick there will add it, and then we can commit that change, and it will pop up a little interface here, again showing us the commit that we're about to make, allowing us to add a commit message. Okay, and we can commit that file, and it's just telling you what it's doing here. So it's added that file, close that, close the commit, and our GitHub desktop app should now know, I've just pressed the button, sorry. The GitHub desktop app now knows that it's a commit behind, and I've just pushed that. I pressed push by mistake. It's pushed that change up. It's added the git ignore and the R project files. They've been added by RStudio, and we could commit those as well if we wanted to. I've not done that yet, but you could do that. And we committed that and we pushed it. So again, we can pull up the repository on GitHub, refresh it, and see that all of our changes, we've pushed them all, and they're all reflected in this repository on GitHub. Okay, so I've gone through quite a lot of things in the last hour. One of the things that I want to do, or one of the things I am going to do, is take last week's video and this week's video and splice them together into one kind of uber Git tutorial, which will probably be about an hour and 3/4 long, but try and clip out some of the not so professional bits and try my hand at video editing. So I'm going to do that. I'm going to kind of tidy up these 2 lessons into one big Uber lesson and publish that as a single video. But these 2 separate sessions will remain separate as well. Will remain in the playlist as well. But that's kind of my plan from between this week and next week. And then next week, as promised previously, I will look at a workflow management system. So we'll take a look at how workflow management works and how it dovetails with the kind of bioinformatics we've been looking at so far. And so that will be session number 52 next Wednesday. So tune back in for that. Very good to see some people on the live stream today, and hopefully there's still people catching up and enjoying these videos. And I will see you next time. Keep